Dear friends, today we are going to discuss about numerical solution of algebraic and transcendental equation. Before going to find how to find a solution for algebraic and transcendental equation, first we need to know what is algebraic equation and what is transcendental equation. An equation involving only algebraic quantities are called algebraic equation. Algebraic quantities are nothing but x power n, means x square, x cube, x power 5, anything. Similar to that, an equation involving non-algebraic quantities are called transcendental equation. The another name of transcendental equation is non-algebraic equation. So what are non-algebraic quantities? Non-algebraic quantities are nothing but logarithmic function, exponential function, trigonometric function, means sin x, cos x, tan, anything, etc. Okay. So first, before going to find the solution of a given equation, first we need to find the location of a root. Means x lies between some real interval. For that, for any equation f of x is equal to 0, there exists two real number a comma b such that f of x has opposite signs. That is, when you replace x by a, f of a may be negative, and when you replace x by b, f of b may be positive. In that case, there always exists one real root between the interval a comma b. Is nothing but x belongs to an interval a comma b, means our final answer lies between a and b. This is called as finding a location of a root. So in every method, first we need to find the location of a root. This is a common procedure for all numerical iterative method. In this topic, we are going to discuss about two types of numerical method. One is Newton-Raphson method, another one is regular falsy iterative method. First, we'll discuss about Newton-Raphson method. The Newton-Raphson iterative formula is given by xn plus 1 is equal to xn minus f of xn by f dash of xn, where n takes the value 0, 1, 2, 3, etc. any positive values. Here xn represents the nth iteration of x, xn plus 1 represents the nth plus 1th iteration of the required root. F of x means the value of f of the function f of x when x is equal to xn. Similar to that, f dash of xn means the value of the derivative when x is equal to xn. So this is called as Newton-Raphson iterative method. We already know what is iterative. Iterative means repeated procedure. First, I will explain the working procedure with an example. So here is an example of an algebraic equation x cube minus 2x minus 5 is equal to 0. We need to find a root of this equation by using Newton-Raphson method, and here in this particular problem I mentioned 4 decimal places. So I want the final answer in 4 decimal places. For that, first we need to fix the calculator for 4 decimal place. So now, first consider the Newton-Raphson iterative formula and observe the formula. Here the requirement is xn, f of xn and f dash of xn. So first consider the given equation as f of x and find out its derivative f dash of x. After finding the derivative, we need to find out xn is nothing but initial approximation. So to find out the initial approximation, we need to use the inspection method, that is trial and error method. In the given equation f of x, first replace x by 0. Then the value of the equation is reduces to minus 5. So we got the negative value. Now repeat the same procedure by replacing x is equal to 1, 2, 3 until you will get one positive value. So now when you replace x is equal to 1, once again we receive the negative value. When you replace x is equal to again the negative, when you replace x is equal to 3, the equation reduces to plus 16. So stop the procedure here because I have opposite sign. So the location of a root means x lies between 2, 3. Means our final answer lies between the real number 2 and 3. So now after finding the location of a root, we need to find out the initial approximation. That is, compare the f of 2 value and f of 3 value. If I compare these two values, f of 2 is minus 1. This is nearer to 0 compared to f of 3, that is 16. So everyone know that minus 1 is nearer to 0 compared to plus 16. Therefore, f of 2 is nearer to 0. So I got this nearest value when I replace x is equal to 2. Therefore, initial approximation of x is 2. Now consider we already have a formula here, xn minus f of xn by f dash of xn, and we have the equation and its derivative. Now construct the table. In this table, the first column contains the number of iteration, and then x value, and then the functional value and its derivative, and the final answer. First here, in the place of n, if I replace 0, the form table reduces to xn means x naught. I have the value of x naught, that is 2, so I will consider that 2 here. So using this x value, I will find out f of xn and f dash of xn using 2, means replace x is equal to 2 in f of x and f dash of x. Now in the formula, replace xn by 2, f of xn by minus 1 and f dash by 10. I got the first iterative of xn plus 1, that is 2.1. So this is the first iteration of x. Now the initial approximation and the first iteration values are not equal, so we need to repeat the procedure again. So in the place of 2, consider the updated value of x, that is 2.1. So now using 2.1, find out f of xn, f dash of xn, and substitute all xn, f of xn and f dash of xn in the formula again to get the second iteration value of x. Compare the first and second iteration value of x. These two values are not equal, so we need to repeat the procedure again. Means replace 2.1 by 2.0946. Now using this, find out f of x and f dash of x. Means here replace x by 2.0946 to get this answer, and in the f dash of x, replace x by 2.0946 to get this. Now substitute x, f of x, f dash of x. I got the third iterative value of x as 2.0946. Now observe the second and the third iteration values are equal. So stop the procedure here. So this is the required answer for the given equation, correct to 4 decimal places. Now we'll go for another example. Observe another equation here, x power 6 minus x power 4 minus x cube minus 1 is equal to 0. Correct to 4 decimal places, given x naught is equal to 2. So the difference between this problem and the previous problem is, in the previous problem x naught is not given, we need to find out that by trial method. But here x naught is given, so no need of a trial method, directly we can go for the formula. So consider the given equation as f of x and find out its derivative, and consider the given x naught. So directly we can construct the table here, n, xn, f of xn, f dash and n, xn plus 1. So x naught is 2, so first consider that x value. So using these two, find out f of x and f dash of x, substitute in the formula. The first iteration is 1.7365. Now replace the x naught by x1, that is 1.7365. Now using this, find out f of xn and f dash of xn. To find out this, replace x by 1.7365 in this equation, and in the f dash, replace x by 1.7365. Now substitute all these three values, the updated values, in the formula. The second iterative value is 1.5498. The first and second iterative values are not equal. So repeat the procedure again until the two consecutive values of x should be equal. Observe in this problem, the third iteration, fourth iteration, fifth and sixth. The fifth and sixth iterative value of x are equal here. So therefore, stop the procedure for sixth iteration. The final answer for the problem is x is equal to 1.4036 for a given decimal places. This is the working procedure of Newton-Raphson method for algebraic equation. In the next class, we'll explain about how to solve the problems of non-algebraic, that is transcendental equation and regular falsi method. Thank you.